be doing about that. However, I'm sure in the end, some of you will probably still not believe me, and there's a little alternate title there for you that you can refer to this by. But to begin with, there's a couple of things that I'd like to digress just so that we can all be on the same page. Most of them are pretty self-explanatory, but I think it's a good idea just to go over them so that we can all come at this from the same angle. Firstly, we do teamwork, which means our code needs to be maintainable and readable. When you work by yourself, whatever, do whatever you want, use whatever you want, that's your own prerogative. But in teamwork, when it comes down to debugging and testing, it's not always going to be you testing your own code. And even if it is, sometimes when you come back a bit later, it's a bit hard to see what you did in the first place. And that also leads on to my second principle of modern best practices. So TypeScript has changed a lot since 1990s. And as such, the way that we do things should change as well. We don't need things such as vars and for int I loops anymore. And now the third one might be a bit more debatable, but in my view, declarative code is a lot better than imperative code. And I'm particularly talking in regards to iterative code. So declarative code helps us know what our variables are at all times because we can see A equals whatever the result is. Whereas with imperative code, oftentimes you have to scroll through the entire piece of code in order to understand what's actually happening and what side effects and the results are. And in this regard, oftentimes you can compile all of that down to the simple array functions that JavaScript provides. Now, almost done. Variables are bad. Now, I'm not just talking about vars. Yes, they are bad, but I'm talking about variables in the literal sense of things that change. Most often, you can just define your thing once, use it where it's necessary, and then discard that variable. The moment we're manipulating the data and the variable, we're basically changing its use, and we could probably just assign it to a new variable. And lastly, use the right tools for the job. It's the modern era, folks. IDEs are very powerful. Make use of them. The IntelliSense features are fantastic. So before we jump in to what TypeScript is, it's important to understand why TypeScript even exists. And we can do that by looking at a brief history of JavaScript. So way back in the mid-1990s, JavaScript was made, and it was bad, very bad. We all know about variable hoisting and all the addition weirdness and arrays and numbers and etc., etc. But it stayed like that for quite a long time, which is why in 2012, TypeScript was made, which was created in order to solve a bunch of people's issues with JavaScript, such as adding classes, type security, enums, and etc., etc. But while this was happening, JavaScript was also changing. And in 2015, there was a big release, version 6, or ES 2015, or whatever you want to call it. But that added so much to JavaScript that was missing from JavaScript. And at the same time, pretty much made TypeScript obsolete. And since 2015, there have been yearly updates to JavaScript. And as they go, they continue to make TypeScript more and more obsolete. And so while it might have been hard to prove in 2015 that TypeScript was obsolete, I'm confident that now in 2024, it really shouldn't even be necessary to use TypeScript at all. So I've been talking a bit of smack about TypeScript, but what is TypeScript? So TypeScript was defined as an exact superset of JavaScript, which means any JavaScript is valid TypeScript, but TypeScript isn't valid JavaScript. Which brings me to my second point. You have to transpile TypeScript back into JavaScript before you can run it anywhere, which is great because now you can catch your errors at compile time. Except modern JavaScript frameworks have the capability to use hot reloading because JavaScript is a just-in-time compiled language. So you'll probably catch your errors just as fast using hot reloads as you would having to compile your code all the time. Additionally, you can't hot reload a TypeScript project without having to do a bunch of additional setup. So in essence, my main gripe with TypeScript is that it's just syntactic sugar that requires a whole extra step to remove. So let's jump into some of the things that TypeScript can do that are definitely impossible in JavaScript. So enums, very useful features that you definitely can't do in JavaScript, except you can. All you really need to do is define an object with the keys of your enums and assign values to them. The one caveat here is that you will need to define a specific value for every enum key. However, most of the time you'll be wanting to do that anyway, as most enums aren't very useful without being associated with an exact value. But as some of you might, if you've done this, might realize that you might lose some IntelliSense functionality of the fact that random value is actually some cool value, and now it's just a string. But let me introduce you to that very cool comment right there. That is JSDoc, or as I like to call it, TypeScript, but better. With JSDoc, I can now specify that random value is actually some cool value, and I can also even abstract away another value's underlying value and type, because we just want to use it as a pure enumeration. So I already started to talk about JSDoc, but why should you use it over TypeScript? Firstly, it implements a majority of the niceties and features of TypeScript, and thus you don't have to worry about losing functionality from porting over. And secondarily, it pairs extremely well with documentation because it was designed for it. So now, while you're documenting what your function's purposes are, you can also document all the types of your parameters, the return values, and all sorts of things that you would need to document. And thirdly, the big one, there's no transpilation needed at all. It's just a bunch of comments, which means it doesn't impact anything at runtime, so you can just run your files straight. I could pretty much leave it there, but I think it's probably a good example, well, a good idea, just to demonstrate a couple more things of TypeScript that you can just accomplish just as well with well-documented JavaScript. So there's interfaces. They're pretty useful at defining what we need in order to accomplish something. That way, we don't have to specify the entire object. We can just specify what we need in order to operate with it. But this can also just be accomplished with the use of JS docs and normal JavaScript. Simply define a class that has certain properties and methods without actually implementing them. And now we can use that interface class in our documentation wherever we need to. Now, you might be asking a little question of, well, how are we now supposed to implement those interfaces in our actual implementations? But that's the neat part. You don't have to, because interfaces aren't real, which is kind of the whole point. So now we can just use duck typing to know if it implements it, because it has the right fields and values. And if you're using a proper IDE, it will do that for you as well. Very cool. And finally, before I open the fight ring, JSDoc can even do generics for you. Now, unfortunately, there is a small caveat here in that it's not as explicit or as built out as TypeScript templates and, generics. So unfortunately, we can't do the whole T extends, blah, blah, blah. But in most cases, this is as much as you would need for most generics. And I guess if you really need to go super in depth with generics, you can use TypeScript. But in the majority of cases, you'll be fine and dandy without it. And if you really still want to use TypeScript, just use it for the definition files. You don't need it for the actual implementation of your code.